Okay. How to solve for an unknown variable. And an is singular in English. So what do we mean by that is there's actually only one unknown variable. Though it appears here, you'll see 3 different times. I'm going to highlight it, okay? 1, 2, 3. We use the same letter to represent it, which means we're really just solving for one. So a really nice or common practice will be to try to get that unknown variable on either the left side or the right side of that equal sign I just pointed to. Okay? It's nice to get all the variables on one side and then all the constants on the other side. But the very first thing we got to deal with, if we take a look at this, is I have brackets. And if you remember BEDMAS, well, I deal with brackets first. My problem is that I have a variable and I have a constant. I can't do anything about it. So in order to actually get to the root of all these, we have to get rid of all these brackets. So we're going to use something called distributive property. That's easy for you? Beautiful. I love the way your face here is like, I know all this. This is great. So I'm going to go quick then, okay? So if I'm going to distribute this 3, I'm just going to draw these in here for our notes because it'll be very helpful when you go to print it later. 3 times r, what's that going to give us?
3r.
Beautiful. 3 times 2?
Plus 6.
Great. Negative 3 times r?
Negative r. Negative 3r.
That's okay. I knew you had it. Negative 3 times positive 1?
Minus 3.
Great. 2 times r?
2r.
2 times 2?
4.
Positive.
Plus 4.
Beautiful. What would I do next here?
You gather all the like terms.
Great. Which ones are like terms?
This one and this one.
So 3r, negative 3r. Any other like terms?
This one, this one. Oh, sorry. That one too.
Okay. 2r is another. Great.
And then that one, and that.
Great. The other ones are constants, which are also like terms. Great. So we only got 2 different types of like terms. So what I'm going to do here is I'm going to focus on all of the constants, the yellows, on one side, and all of the blues, or the coefficients of variables, on another. What's your preference? Variables on the left or the right?
The left, because there's already 2 on that side.
Great. I'm going to tell you by the same logic, there's also 2 constants on that side. But that's fine. Let's go with that. So if I'm going to move this over here, we're going to do a lot of mental math. I'm not actually going to write a lot of this out. If I move that over to this side, what's it going to become?
3r minus 3r minus 2r.
Great. And I'm going to move these other 2 to the other side. What is it going to become on the right side of the equation?
4 minus 6 plus 3.
Great. Very good. So I'm going to rewrite it. 3r minus 3r, like you said, minus 2r. Put in red the one change there. On this side, we had 4, and you said minus 6 plus 3? Great, yeah, the operation is just flipped in front of the other one, so this is good. We got 3r minus 3r. What's that become?
0.
Cancels out. So we're left with 2r is equal to, what does this one equate to on this side?
Negative 2. 1.
And then I got to get r technically by itself. That's the main goal here. So if we're going to get r by itself, what do I got to do to both sides?
Divided by negative 2.
Excellent. What's my answer going to be in the end here?
Negative 1 over 2.
Is equal to what?
Is equal to r.
Great. Exactly what you got, right? Our problem here is that when we're checking, we're running into an issue. So let's talk about how to check something like this. We're going to write the exact same equation over here, but this time I'm going to replace all of the r's with negative a half. Okay? Plus 2 minus 3 negative a half plus 1 2 running out of room, negative a half plus 2. Amazing. Now, I could go about distributing, but remember the very first thing I said is when we have brackets, we try to simplify, and we can. So there's absolutely no reason to do that. So I'm going to get rid of all my distributive stuff here. I'm going to simplify my brackets now that we actually have number values. So 2 and negative half is going to be, do you know?
3 over 2.
Okay, so you're going to turn it into, so one of the first things we need to do is, if I simplify this, I'm going to simplify this bracket before I actually distribute.
Oh, sorry.
That's okay. So I'm going to do 1.5, which as an improper fraction is just 3 over 2. Okay?
Yeah.
We'll do improper so it's a lot easier when we go to multiply after, okay? Here, we get -3 multiplied by 1/2. And in this bracket, we have 2 times 1.5 again, so 3 over 2. Okay? Do those fractions make sense to you? When we simplify?
Wouldn't that one be? Wouldn't this one be 4 over 2?
Let's take a look. So -1/2, and whenever we add or subtract fractions, we should have common denominators. So technically, this is 2 over 1, but I need to make it a common denominator. So I'm going to multiply both the top and the bottom by 2. Okay? So now the question reads -1/2 plus 4 over 2. Denominator will stay the same.
Oh.
-1/4 is 3 over 2. Cool? Good. It's always good to ask questions if you're unsure. So we got it. 3 over 2 works out really nice. If we go to multiply, technically again, we want to multiply fractions by fractions. Any whole number can be turned into a fraction by just putting it above 1. So when I go to multiply across, I do the top by the top and the bottom by the bottom. So 3 times 3 is 9, and 1 times 2 is 2. And this one's going to be a -3 over 2 is equal to 6 over 2. Okay? 9 subtract 3, 6 over 2. We got it. Okay? Though we had to work with fractions, which is sometimes more difficult for us, if we simplify those brackets, it makes the process a lot easier because there's far less terms to work with. Where if we distribute, we're going to get 2, 4, 6 different terms, and those are probably going to be fractions also.
Wouldn't the answer be 3?
It is, 100%. You can divide that order and goes 3 over 3. But we got to this point and noticed that visually it's the same. I don't technically have to go any farther because the goal here is just to make sure that the left side is equal to the right side, right? But you can always simplify farther. In fact, I can break this down to 1 plus 1 plus 1 is equal to 1 plus 1 plus 1. All of that is the exact same thing, technically. Okay? So,